you very much, Oliver, and good morning, everybody. As Oliver mentioned, accessibility is my field, which for me it means focusing on the engineering aspects of accessibility. Accessibility, as you'll be very well aware, is a far greater topic than that. It incorporates interaction design, usability, graphic, creative design, and many more different things. But the area that keeps me interested is what happens in the browser, especially in relation to the code that we use. And this talk focuses on some of the ways we can all too easily blow things up without really intending to.
5, 4, 3, 2, 1, go. You're only supposed to blow the bloody doors off.
And this is very much how it can be on the web, in all manner of areas, come to think of it. But in accessibility terms, there are a lot of moving parts that go on in relation to the browser and the code that we write and the way the two of them interact. And when you throw in an assistive technology like a screen reader on top of it, there are even more things to take into account. And so it's very, very easy to do something with the best of intentions to make an experience more accessible for someone, but just accidentally or inadvertently get something wrong. So what I'd like to walk through today is just a few of the things that I come across pretty frequently on the web where people have set out to do the right thing, set out, if you like, to blow the doors off, but instead have taken out the entire van and most of the surrounding locale with it. So screen readers, Aaron mentioned this in his talk, of course, this morning, so it may well be a familiar thing for many of you. But it's a piece of software that translates what's on screen into synthetic speech. They're available on every platform, so Android, iOS, macOS, Windows, and even Linux. There are either free or integrated screen readers available on all of those platforms. So they're pretty ubiquitous in terms of the way blind and some partially sighted people, as well as people with dyslexia and autism, are consuming content. Screen readers are very capable. They can do all sorts of things. So, for example, they can read text.
ARIA Accessible Rich Internet Applications is a suite of specifications from the W3C. Knowing which specification has the information you need isn't always obvious. So is a brief.
And they don't just read text from top to bottom. They are capable of navigating by character, by word, by paragraph, and also navigating by different HTML elements. They're very good at identifying what different types of content are based on the HTML elements that have been used. For example, headings.
Take heading level 1. Quick guide to the ARIA specifications heading level 2 link. Using the ARIA current attribute heading level 2 link.
So that information you can hear where it announces the heading level and also the fact that there's a link contained within several of these headings. That's obviously not information that's available in the DOM in the browser. It's inserted by the screen reader based on the information that it's picked up from the browser about the HTML that's being used. And it provides the visual equivalent of what's probably obvious to people looking at the page. Forms are another interesting area. When screen reader users navigate by different HTML elements, they use letter shortcut keys. So most of them follow a pretty standard set of shortcut keys. H moves between headings, L between lists, T for tables, G for graphics, and so on, until pretty much all of the alphabet is taken up, which, if you're thinking ahead of me here, you'll understand represents a bit of an interesting challenge when you actually want to use those letter keys for entering common or garden text into a form, for example, a bit like this.
Tab, favorite drink, edit, T-E-Q-U-L-A. Tab, which type, combo box, blanco, reposado, Jordan.
So in this case, the letters were just, or the keys for the letters were just being passed straight back through to the browser. The screen reader was effectively ignoring them. Or in the case of the combo box, the second field there, the arrow keys were just being ignored by the screen reader and passed straight back through to the browser to do what they do normally if anyone else were to use those same keystrokes. And this is a really important part of understanding how screen readers work on the web. There's a keyboard intercept chain, and it's slightly different in different contexts. So Windows, traditionally, screen readers like JAWS and NVDA have intercepted all keystrokes, and if they need those keystrokes, for example, to navigate to a heading, they will use them. It's only when they switch into what's called forms mode that they understand that they can discard that key for themselves and let the browser get on with treating that key as it normally would be treated. On macOS, it works a little bit differently. The thing happens the other way around. So the browser gets first dibs on the keys that are being pressed, and if they're not needed by the application or the rendered content, then they're passed back to VoiceOver, which is the screen reader on macOS and iOS, and they're picked up then for use by the screen reader. What this means is for the two screen readers I mentioned on Windows, JAWS and NVDA in particular, there's a problem when we provide shortcuts with JavaScript. Now, this is a tremendously helpful thing to do. I don't want you to think for a moment I'm suggesting that we shouldn't do it. Keyboard shortcuts provided in this way are hugely helpful to the millions and millions of people who use keyboards as their primary input device. But for those of us who use one of the aforementioned screen readers on Windows, there's a little bit of a problem because the screen readers intercept the keystrokes that we want to use and almost always have something better to do with them than the JavaScript shortcut that was intended. So, for example, on the Twitter website, the J shortcut key will load the next tweet or move to the next tweet. So when they... so the problem is, this is what happens when, for example, you use JAWS to try and activate that J shortcut key on the Twitter website.
Jump to line dialog. Enter line number 1 to 954, and...
J is a shortcut key in the JAWS screen reader for allowing you to move to a particular line of code in the web page. Personally speaking, I have never yet found a use for that particular keystroke. I'd much rather it did what it was supposed to do on the Twitter website, but there it is. The website never gets hold of that keystroke, and so the JavaScript shortcut is effectively broken for people in this audience. The solution's really simple, is provide the JavaScript shortcuts anyway, but make sure that there are alternative methods for people to be able to get at it. And these methods, of course, need to be accessible. So it might just be a button to load more tweets. Something as simple as that is good enough. I will point out at this point that Narrator as a screen reader also on the Windows platform is the one that comes integrated with Windows 10. Aaron was demonstrating earlier. It doesn't have this problem as a rule because it tends to use a different model thanks to some of the changes in the Edge browser and the way screen readers and browsers interact, but that's a conversation for another time. So how does this all work? Well, we have platform controls all the way through the operating system, applications, any user interface pretty much. We've got a whole bunch of software controls that we're very, very familiar with. For example, a checkbox. This one toggles a bold state for something somewhere. And if we were to look under the hood of where this control was found in the interface, we'd discover there's some accessibility information available about it. It has a role, a checkbox that describes its purpose in life. It has an accessible name or a label that's bold. In this case, it matches the visual label that's on screen, and it tells everybody what this checkbox will do when it's toggled. And we can also find out something about its state. It can be focused on, it is currently focused, and it's also checked. And all that information is available to assistive technologies like screen readers using platform accessibility APIs. Like screen readers, these APIs are available on every platform. Some, for example, Windows, have 2 or 3 different APIs to choose from. These APIs are not developer APIs, though. They are used only by assistive technologies like screen readers. So it's a very closed life cycle from our point of view as developers. But these APIs, through these APIs, screen readers and assistive technologies can query that accessibility information that's available at the platform level or application level. They can also use those APIs to query the same information for rendered web content in the browser. And in fact, if we use some standard HTML to recreate that same checkbox, using a label element associated with an input with a type of checkbox using for and ID attributes, we'll discover that the accessibility information is exactly the same. The role is checkbox, the label is bold, and the state information is exactly the same. If you're curious and you want to know how different HTML elements are interpreted in this way, the HTML accessibility API mappings document from the W3C is the place to go. It'll tell you for every single HTML element and attribute how it's represented to the platform accessibility API. So you can discover a lot of what screen readers in particular will pick up when you write HTML code. What happens in the browser is that when you load some code into the page, it creates the DOM tree, and it uses this to do a bunch of stuff, not least, of course, create the visual rendering that most of us interact with. But it also creates an accessibility tree, and it's this that the assistive technologies interact with using the platform accessibility APIs. It's a tree in the same way that the DOM is, so it has a whole bunch of nodes, but in this case, the nodes only contain accessibility information about the content that's on the page, things like the role, accessible name, and state of a particular object. So this is what happens, is that the DOM gets loaded in the browser. The browser uses that information, it creates the accessibility tree, and then screen readers, particularly those on Windows, use the platform accessibility APIs to grab a copy of the page. It's known as a virtual buffer, and it's this that screen reader users in particular interact with. If anything changes in the DOM because of user interaction or scripted interaction, the browser updates the accessibility tree. That fires a change event, essentially, that something like a screen reader can listen to, and it can go away and query the changed or the updated or the revised information in order to let the user know what happens. So it's a pretty efficient ecosystem in many ways. But what happens when we're not using native HTML? We live in days where we have JavaScript frameworks that will quite cheerfully repurpose a span to be a link just because somebody thought it was a good idea. More interestingly and excitingly, we are in an era where we're looking at custom elements and web components. So we're using div and span elements in particular as our primitive building blocks to really start pushing our creative imaginations in terms of the interface components that we might want to build. So we use ARIA, Accessible Rich Internet Applications, to polyfill a lot of the semantic information that is needed by screen readers in particular. ARIA, although intended for use by any assistive technology, is pretty much only supported by screen readers. I think Dragon Naturally Speaking 13, a speech recognition tool, has very, very limited support, but to all intents and purposes, this is all about support for screen readers. So ARIA is a set of roles and attributes that you can use to add all sorts of different semantic information, like roles and state and accessible names and descriptions. The first rule of ARIA, though, is don't use it. If you can use native HTML and get away with it, do it. Don't worry about it doing it from an accessibility point of view. Actually, do this from a sheer laziness, got better things to do with my time point of view. You get so much accessibility for free when you let the browser do the hard work for you. And we'll see some examples of this as we go through it. But seriously, if you want to go and grab an extra coffee or a donut at lunchtime instead of just working through, you want to get a whole bunch of stuff for free and save yourself some coding time, use HTML wherever you can. It's a serious win in terms of time and efficiency. A simple example I did a couple of months ago suggested that you can actually increase the amount of code you have to write by 20%, even when you're making some custom element accessible that's a pretty simple element, never mind a whole interface or application UI. So if we take native HTML, just our favorite button example, why not? It wouldn't be an accessibility presentation without one. We will discover that we actually get a lot of information for free. And this is how a screen reader would deal with that particular thing.
Tab to keyboard button.
So you can tab onto it, so the browser automatically makes it focusable for you. It exposes in the accessibility tree that it has a role of button. The screen reader recognizes that, and it tells the user that they're dealing with a button. And that sets up expectations. It's a button, so I know I can use the enter or space key to activate it. It's all pretty good and straightforward. So there are times, though, when you need to use ARIA. As I said, we've got plenty of use cases where we want to use divs and spans in particular, which don't have very good accessibility information of their own. They don't have a strong role, they have no state, they're not interactive, you can't focus on them. So we need to do things sometimes to use those elements, and we then need to add in the accessibility information. So for example, let's take this as a span with some class design to make it look like a button, we presume, and some JavaScript that would make it function like a button. We have missing semantics. So there's no semantic information. Oh, sorry, that's the wrong example. It's a toolbar, sorry. There's no semantic information in there. It should be a toolbar with some conventional word processing buttons. But this is what happens when we look at it with a screen reader. So, indeed, it does. It just has missing semantics. So there's no button information, and it's not focusable, so we can't move into it. So all we hear is just the word tequila. There's no information to tell me what this thing is or how to interact with it. If you choose to add in some semantics, so we can use the tab index attribute with a value of 0 to make this thing focusable, and we can add the role attribute from ARIA with a value of button, then we can start polyfilling some of that missing information. And this is what happens when we do.
Tab, tequila button.
It's exactly the same as though we'd used the button element. And you'll start to see what I mean about extra code. We could have just used a button element instead of a span element and skipped the need to add in 2 extra attributes to start making this thing more accessible. So it really does come back to that use HTML where you can. When you use ARIA, don't break native semantics. It's really easy to confuse screen reader users when you don't really mean to. So, for example, if we took something that, to all intents and purposes, was a button, but we gave it a role of heading and an ARIA level using the role attribute with the value of heading and the ARIA level and a numeric value, it starts to do some very strange things to screen readers.
Heading level 1 tequila.
So to the poor screen reader user like me, they think they're dealing with a heading, and it's all good, except it's actually a button. It looks like a button, it functions like a button, I just haven't got the faintest idea that it is a button. So it's really tempting to go adding roles to elements in HTML and overriding their kind of natural purpose. Sometimes there are good use cases for doing that, but be very, very careful when you do, because it's incredibly easy to start breaking things for screen reader users if you apply the wrong role to the wrong element in the wrong situation. You need to make it work with the keyboard. This is the other thing about ARIA. When we create custom components, particularly things like tab panels and progress bars and toolbars and menu bars, we need to add in the keyboard support quite a lot of the time. And that's our responsibility as developers. Using a role with ARIA does not confer any kind of behavior as a rule. We have to do that for ourselves. Sometimes it means we have to supplement existing interaction. So a common design pattern we see is a link repurposed to be a button. That's pretty common. Links by default in browsers can only be activated using the Enter key, whereas I mentioned before, the expectation with a button is that you can use Enter or space. So we just have to script a little bit of extra keyboard support here to acknowledge that when someone hits this link with a spacebar, because to all intents and purposes it looks like a button and behaves like a button, it also has the expected keyboard interaction. Sometimes we need to provide all interaction. So if we take our span-based fake button again, this time we have to provide all the interaction because the browser doesn't do it for us at all. So again, we listen out for the key codes, this time for both space and enter, and if either of them are detected, we go ahead and perform whatever function the button is intended to do. And that's a very good question. What is this button that we've been looking at all this time intended to do? Well, some quite interesting things, as it turns out.
Tab, tequila button collapse. Enter, expanded. Blank, makes me happy.
Now, you see what we'd have missed if we thought that was a heading and couldn't focus on it or interact with it. So, trust me, there are some good reasons for getting this accessibility malarkey right from time to time. If you want one good way with ARIA to completely blow the entire van up, it's to use the application role. In my opinion, this should never have really been added to ARIA. Basically, what the application role does, it says for everything inside this container that has the role of application, treat it as though it's an application software interface. Screen readers have very simple interactions with software applications. You can pretty much tab around them, sometimes use arrow keys, hit the Enter key, and occasionally the space key, and that's it. All your screen reader navigation commands for reading and navigating text or moving from one object or element to another are gone when you use the application role. So the general advice for using the application role is don't ever do it, because if you do, then the responsibility is on you to provide all the keyboard functionality that a screen reader user might need. And that's an awful lot of work when you really get down to it. There's a kicker, though. The application role isn't the only role that does this. There are actually a whole bunch of them, including the tab list, if you're creating a set of tab panels, progress bars, menus, toolbars. All of these roles, when you apply them, have exactly the same consequences. You need to provide all the keyboard support through JavaScript, because if you don't, there is none for a screen reader user. So, for example, if we take a set of tab panels that look the part, they've got all the ARIA in for the right roles, the tab list to say it's a list of tabs on the screen and all the rest of it, but we don't provide the keyboard support through JavaScript, this is what happens.
Tab, blank of tab selected, use JavaScript plus Alt plus N to move to control elements.
So we can tab onto that first tab, but that's it. We can't cycle through the tabs. We can't move from here. All we could do is just tab away again and through the rest of the content that was presumably on the page. There's absolutely no way for a screen reader user at this point to be able to interact with that set of tab panels. And so there's a whole bunch of content there that's just going by completely unnoticed. So we need to do some scripting. The first thing we need to do is just make that entire widget a single tab stop. If you had to use the tab key to move through every single tab in a set of tabs, that would be a lot of key presses. So we actually make it a single tab stop. So it means you can tab onto the tabs and in one more key press, tab away from it if you're not interested in interacting. And to do that, we set tab index 0 on the currently selected tab. That adds it to the keyboard sequence. And we set all of the other tabs in the tab list to have a tab index of -1. That takes them out of the keyboard sequence. So anybody using the tab key again now will just skip over the rest of those tabs and carry on their merry way. What we do then is when we detect that someone is cycling through those tabs to select them, whichever tab currently has focus, we update its tab index to be 0 and update all the others to be -1. And this massively simplifies the keyboard experience for people who can't use a mouse to just point and click at whichever tab they want to look at. We also need to provide all the event listeners for the keyboard interaction. In this case, when someone has tabbed onto the set of tabs, we need to listen for the arrow keys. So left and right, up and down, respectively, will cycle through the tabs. And as each one is selected, the roving tab index gets updated. And of course, the corresponding tab panel content is brought into view using pretty much standard styling techniques. And when we do, the experience for a screen reader user is radically different.
Tab, blanco, tab selected, use JAWS key plus Alt plus M to move to control element. Repostado, tab selected, use JAWS key plus Alt plus M to move to control element. Joven, tab selected, use JAWS key plus Alt plus M to move to control element.
And if you're curious, that JAWS keystroke moving to controlled element is courtesy of the aria-controls attribute. Sadly, it's the only screen reader to support it, but it's a very useful way of saying, in this case, that particular tab controls that particular tab panel. So it provides a shortcut for jumping from the tab that you've just selected to the actual content that's now being displayed. There's a new thing on the horizon that gives us our last and final way, or potential way, of really blowing things up on the web in terms of scripting. It's called the Accessibility Object Model. And it's a JavaScript API that will give us as developers access to the accessibility tree, just as the platform accessibility APIs do for assistive technologies. It's being developed currently by Google with help from Apple and Mozilla. And it has 4 phases of development. Phase 1 will introduce the ability to modify information that's existing in the accessibility tree. Phase 2 will let us listen to actions from assistive technologies that are bubbling up through the accessibility tree. Phase 3 will let us introduce entirely new nodes into the accessibility tree. So things that don't exist in the DOM have never existed in the DOM. We can, or will be able to add straight into the accessibility tree. And this is where the real potential for blowing things up comes in, because we can have 2 completely divergent tree interfaces to the browser content. The last one will give us access to query the entire tree and access the computed properties of accessibility nodes. So phase 1 has just landed experimentally in Chrome Canary behind the flag. That's the flag there if you're curious. So you can start experimenting with some of this. So we take a very simple piece of HTML code, again, a span and a div element with no accessibility information of their own. And I'll stress again, this is no good way to carry on with production code, but it's a useful way to illustrate a point. And we're going to use them to make a very simple disclosure widget with the span acting as the button and the div containing the content to be shown or hidden. In our script, we do our standard thing. We create DOM node references to both of them so that we can reference them later. And then we start setting the properties in the DOM. So we set the tab index attribute with a value of 0 on the span to make it focusable, just like we did before. And we set the hidden attributes on the div to hide it away until we want that content to be visually shown. Totally standard operating procedure so far. But then what we can do is start using the AOM. So we now skip the DOM entirely and start manipulating the information in the accessibility tree directly. So for each of the DOM nodes that we've got references for, we can now grab the accessible nodes from the accessibility tree. So they're corresponding pieces of information in the accessibility tree. We can start setting some information on them. We can also, so we can do things like set the expanded attribute on the span, which will indicate the collapsed or hidden status of the disclosure widget. All the properties in the AOM correspond to ARIA attributes. So where we would have used ARIA expanded as an attribute, we can now just use the expanded property. And we can then, we can then create an accessible node list. And this basically is an array that contain one or more accessible node objects. We use this instead of needing to pass ID values to certain ARIA attributes. So in this case, in our function, what we're doing is going to set the ARIA controls attribute that I mentioned before, except this time we're just going to apply the AOM controls property straight on the accessible node. And instead of passing it an ID value, we're going to pass it the accessible node object that represented the div of the containing for the content. We're also going to change the state of the expanded attribute, pretty much like we would have done with ARIA expanded. We're going to set it to true when the widget is expanded, set it back to false. And lastly, just update the hidden attribute to make the visual availability of the content on a par with the accessibility information. Lastly, we add the event listeners in, so whether you click on this or treat it like a button with the keyboard, we've got the same accessibility and availability there. And this is what happens when we do all the accessibility using the AOM instead of standard node references in the DOM. Well, we would have done had it not been one of those days. But essentially, what we would have heard is that pretty much like the buttons that we saw earlier, you can tab onto it with a screen reader because it's focusable now. But more importantly, through the accessibility tree manipulation, we hear the role of button, just like we did with the button element or setting the role of button using ARIA. And we hear about the expanded and collapsed state, exactly like we did in the previous example where we knew what the state of the object was. And we can use the ARIA controls attribute like we heard in the tab panels to move straight to the content that's just appeared visually on the page. And to all intents and purposes, this is exactly the same semantic information, interaction, keyboard focus and interaction that happens when you use the details and summary elements, for example. So again, ways to save yourself time and energy with accessibility. Yeah, use native HTML whenever you can. So, having finally got through these slides, which were definitely not playing for my team today, there are lots of ways when you set out to do some good stuff in terms of accessibility that you can inadvertently cause problems. Don't let this put you off trying for a single moment, because all the accessibility, the work you do is incredibly important. It makes an extraordinary amount of difference to people like me who need accessibility. But just be aware of some of the pitfalls so that when you aim to take the doors off, you don't end up blowing up the entire van. Thank you very much for listening and putting up with my slides.